Hello, everyone. Today we are going to talk about the Tiny Recursive Model. It's from a research paper that just got released. The research paper is named Less is More: Recursive Reasoning with Tiny Networks. To give some background, we'll go through this hierarchical reasoning model that released in 2025. It wasn't a massive LLM, just a clever architecture that used two small neural networks working at different frequencies to simulate thinking in steps. HRM showed that reasoning isn't about size, it's about structure and iteration. Currently, Tiny Recursive Model, it's based off this architecture, takes that idea even further, shrinking the architecture down to just 7 million parameters while improving performance. It outperforms some of the biggest language models on human-style reasoning tests, ArcAGI-1 and ArcAGI-2. Let's start with the benchmark itself. The abstraction and reasoning corpus, or ArcAGI. Imagine you're given 3 small puzzles, each with an input grid and its output, and your job is to figure out the hidden rule, color symmetry, path or shape rotation, and apply it to a new test grid. Humans do this effortlessly, but for machines, it's incredibly hard. There's no text, no training labels, or no prior examples of the same puzzle. You have to infer the rule purely by reasoning. That's why ArcAGI is often seen as an IQ test for AI systems, measuring generalization, abstraction, and reasoning. There are 2 versions. ArcAGI-1, the original dataset, already tough for large language models GPT-4 and Gemini. ArcAGI-2, released in 2025, even harder with tasks that can't be brute forced or overfitted. Most LLMs and transformers process input once and output an answer. One shot. TRM, on the other hand, thinks recursively. It keeps 2 internal memories. Z, a latent reasoning state, a scratch pad where it stores what it's thinking. And Y, its current solution, what it believes the answer might be so far. At each step, the same small 2-layer network refines these states. It updates Z multiple times using the puzzle input and current guess. Then it updates Y, improving its solution. This loop repeats a few times, letting TRM repairs its own mistakes, just how humans iterate on a problem before finalizing the answer. The training is clever too. Only the final step of this loop gets full backpropagation, making it stable and efficient even on small datasets. Let's look at the numbers. On Sudoku Extreme, TRM hits 87% accuracy. On MazeAD, around 85%. On ArcAGI-1, 44.6, beating HRM, which is a 27 million parameter model, and even models GPT 2.5 Pro and DeepSeek R1. On the tougher ArcAGI-2, it still manages 7.8%, where many LLMs fail completely. All that with just 7 million parameters. TRM isn't a general chat model. It's a reasoning core. Imagine plugging this into a large language model as a thinking module, a reasoning engine that can handle structured logic, puzzles, or planning. It's also a glimpse into the future of compute-efficient AI, smaller, recursive model that achieve reasoning depth through iteration, not size. This is a simple diagram which I've made using Gemini Nano Banana. This is not an official diagram, so please do ignore the typos in this diagram. It is just for imagining a future where TRM would probably be a small reasoning engine that is plugged into a large language model. The Tiny Recursive Model shows us something profound. Intelligence isn't just about scale, it's about structure and iteration. Would you rather have one big model that knows everything, or a small model that can actually think? I'm Raj Murray. See you in the next deep dive on the future of reasoning AI. Thank you.